Okay, in this video, we're going to take a look at the difference in flow rate or viscosity of three different temperature fluids. So all three of these are Karo corn syrup. The first one here is at 57.3 degrees Celsius, and we're going to add a sphere in there once we take the temperature probe out. And we'll see how fast it can now flow through this liquid. Let me see how quickly that one went. The second one we're going to place in the corn syrup. And we see this one's at room temperature, so our temperature drops pretty significantly. We're going to let this stabilize. Kind of move it around to get that stabilized temperature. And we're at about 23.2 degrees Celsius here, 23.1 maybe. And we'll remove that, let that syrup come off. It is obviously a little different now. And we will drop a sphere in here and be able to record the time it takes for that sphere to hit the bottom. And then finally, we're gonna go into our corn syrup that has been cooled by an ice bath. It's warmed up a little bit from the ice bath, but we're still sitting at about 13 or so degrees Celsius. So again, still colder than that room temperature one. So we're at 13.5 degrees Celsius, and we'll take that out. And we'll drop the sphere in and time that one. Now, visually, it was pretty obvious to see that there is definitely a difference in speed at which the warm one dropped versus the room temperature versus the cold one, okay? But we should be able to use the video data then to actually time this and graph this relationship. And it finally hit the bottom there.